So today we're going to be looking at solving exponential equations. All right. So the big key for solving exponential equations is this little guide right here. Okay, it says if x to the y is equal to x to the z, then y equals z. So what we're trying to tell you is that if your exponential equations have the same base, the base will go away and the equation becomes based on the exponents. You just set the exponents equal to each other and then solve. All right, so let's see how that looks. So here we have 5 to the 3x equals 5 to the 9th. So because the bases are the same, we can take our exponents, 3x and 9, and set them equal to each other. And that becomes our equation. And we just solve it like we've been solving equations since you were in 5th grade or 6th grade or whatever. So we divide both sides by 3, and we get x equals 3. All right. So try this one out on your own. Pause the video, try and solve this, and come back when you're done. So hopefully you've tried it and came back, and we're just ready to see how you did. So again, because the bases are the same, we can take the exponents and set them equal to each other. All right, when we solved it, you'll find out that x is equal to negative 6. Now, there are some situations where we have exponential equations where the bases aren't given to you or they're going to be the same. So we have to do something to change them. Okay. Now, in certain questions later that we're going to see later on, not today, you're going to have bases which are so different that there's no way you can change them to be the same thing. Okay. But that's a different type of topic. And the questions we have here, the bases are similar and they have a common base someplace hidden inside of them. So we want to figure out how to change that 100 into a 10. Now people will just say, well, get rid of a 0. Well, you can't just get rid of a 0. They'll say divide by 10, but we're not trying to divide the number and change how much it's worth. We're just trying to change how it looks. So it's still worth 100, but it doesn't say 100. It has said something else, but it's still worth 100. Okay, and to do that, we have to use exponents. So we're going to have our basic equation that we started with, but we're going to turn the 100 into something else. And the something else is going to be 10 squared. Okay, so 10 squared is still equal to 100, but we've just changed the way it looks. Now, in part of these equations, one of the key pieces is exponent rules. You have to abide by the rules of exponents. And one of them is when you raise a power to a power, like we have with 10 squared to the 4th, you're going to multiply the exponents. So this is actually going to be 10 to the x equals 10 to the 8th. Okay, and now that the bases are the same, we can get rid of the 10s as bases, and we can just set the exponents of x and 8 equal to each other, and that is in fact your answer. All right. So try the next one. All right, find a common base. All right, using exponents, and see if you can solve the equation. So take a moment, pause the video, see what you get, and come back and see how you did. So hopefully you've paused the video and you're back now. Okay, we have 2 and 8 to go over as bases. All right, 2 is about as small as you're going to get, so you can't really get smaller base than 2. So we have to change the 8 into something else. So if we look at this, what can 8 be that has a base of 2? So again, we're not dividing it by anything, we're not subtracting by anything. We have to change the number into a base with an exponent that will also equal 8, but has a base of 2, and that would be 2 cubed. So 2 to the 3rd power is 8. So we're not changing how much it's worth, we're just changing how it looks. All right, again, using the laws of exponents, we have to multiply 3 times 4x together to get 12x. All right, now that the bases are the same, we can get rid of the 2's, set x plus 33 equal to 12x, and solve for x. You'll find out that x will equal 3. Now the next problem here adds another little wrinkle, and it again deals with laws of exponents. So we need to get that 25 not only changed to a different base, but we have to move its positioning. Okay, right now it's a denominator, we need to make it a numerator. And we can do this using laws of exponents. Okay, so first thing to think about is how to change 25 into a 5. Again, we're not dividing. All right, what number raised to a power gives you 25? Well, that would be 5 squared, but that's on the denominator of your fraction. You need it to be a numerator. one of the other rules of exponents is that if you change an exponent to be a negative, it flips from either the numerator to the denominator, or it goes back up from the denominator to the numerator, depending on where it is. Because our problem is 25 in the denominator, we put a negative sign in front of the exponent. It makes it go up to the numerator. It changes position. So if we have 5 to the negative 2 power, is the same thing as 1 over 25. Now that we have the same bases, x will equal negative 2, because that's your only two exponents. All right. This is another tricky one. In this case, we have 4 and 8 as our bases. Well, if you square 4, you're going to get 16. If you square 8, you're going to get 64. So 8 and 4 need to find a common base between the two of them. In this case, what we need to do is we need to change both of them to have different bases. So what common base do both 4 and 8 share? Well, they share a common base of 2. 2 squared is 4, and then 2 to the third is 8. All right. So again, now that we have these bases, we have to take our exponents and multiply the exponents together. So we have 2 times x plus 3 and 3 times x plus 6. I'll give you this. Now again, because the bases are the same, we can set the exponents equal to each other and then solve for x. When we do that, we'll find out that x is equal to negative 12. All right, so we've done a bunch of different examples. Here's another one. Please try this one on your own. See what you come up with. So pause the video, try it, and come back when you're done. All right, so hopefully you've tried it. You've maybe struggled a little bit. Maybe you got it. Maybe it's easy. All right, either way. So we need to make the 64 and 4 have the same base. Well, 64 is a denominator, so that means we need to move it up, which means it's going to have a negative exponent. The other thing is 64 has to find a common base with 4. All right, and the answer is going to be 4 to the negative third. So 4 to the third gives you 64, and the negative sign in front of the 3 raises the 64 from a denominator to a numerator. Now that the 4's are both common terms, we can delimitate those bases and set negative 3 equal to 3x. We solve for x by dividing by 3, and we get x equals negative 1. All right, so let's try this one more time. Take a pause on the video. See if you can find a common base to solve the equation. When you're done, come back and see how you did. Okay, so hopefully you're done. We can see how you worked out. So 9 and 81. We've got to find a common base. Again, we're not dividing. We are finding an exponent that could work based on a base number. So 9 has to go to the numerator, so that means we're going to change its exponent to be a negative. Well, we're going to use the base of 9 and raise the 9 to a negative 1 power. So it becomes positive 9 to the negative 1 power. Ooh, that was a little bit tongue-tiedy. All right, and then we go to the 81. Okay, what number as a base gives you 81? Well, that would be 9 squared. So we're going to change the first 9, the 1 over 9, to be 9 to the negative 1 power, and the 81 to be 9 squared. Then you'll multiply the exponents together so that you have negative 1 times 2 and 2 times x plus 5. All right, now that the bases are the same, we can get rid of the bases and set the equation equal to each other and then solve for x. All right, and that's the end of the notes. Please, I implore you to try the practice and ask questions if you're having problems. If you're not having problems, you can still ask questions. Good luck.